Hi guys, of course I have everything up. Okay, here we are. All right, so I wanted to talk about the third type where the denominator has quadratic factors. We didn't really get to this in first period and then we didn't finish this in third period. So the first thing we do, just like always with our partial fractions, and one thing I wanted to talk about is when it is a partial fraction. I don't think I'm clearly said that today. I think we were all a little rattled with the inefficiency of Schoology this morning. So partial fractions can be used anytime we have a fraction that has the degree of the denominator is larger than the degree of the numerator. So that's up here, the degree of the denominator is the greater one. So if we have the degree of the numerator bigger, then that's like an improper fraction. And so we would use long division first, and then perhaps we might need to use partial fractions on our remainder. Okay, but that's not going to be a nuance that we're looking at. It's just kind of in where to fit this in your big scheme of how do I take integrals. Okay. So we always start by factoring the denominator as much as possible so we can get those factors as small as possible, making our life as easy as we can. Now, that theme of how I talked about the numerator has a smaller degree than the denominator comes up specifically here. So both the first two factors are linear factors, right? They have a degree of 1, meaning the numerator is going to have a degree of 0 or just be a constant. That's why all of our previous examples just had an A, a B, C, D, whatever in the numerator. However, this one, we have a quadratic factor. As in, I can't factor my quadratic anymore. The smallest factor is quadratic. So just following that pattern, our numerator must be linear. So if you have the x squared plus 4 as your factor, or if your factor is a quadratic, then you need to have that linear numerator. And so that's the big difference in the type 3 problems, okay? Other than that, they set up the same, so we finished factoring it. A over a first factor, B over a second factor, CX plus D over our third factor. Same process, so we multiplied both sides by our denominator. I'll let you guys work through this. Hopefully I didn't make any sign errors. Be very careful with your signs so that they don't like morph and change, because that will mess you up. Going through, I let x equals 0 first because I have this factor of x, and so when I make x be 0, then that's going to wipe out anything that's multiplied by that, which makes our life lovely, and we get a equals 2. Then I used x equals 1 because of our factor up here, and that gave us b as -2. So then that's where we are going to pick up. So right here, there isn't anything that we can use that will make x squared plus 4 be 0, unfortunately. So we just need to choose another x value. Now, the nice thing is we can choose any x value we want. I guess the sad thing is we've already used x equals 0 and x equals 1, so we can't use either one of those. So let's just use x equals 2. It's small, it's positive, both good things. So we're going to substitute back in. So replacing in this equation all of our x's, and then don't forget to use the a and the b that you all, oh gosh, I hate it when it does that. The a and the b that it already found, go ahead and use those values as well. All right, so it's 2x cubed minus 4x minus 8. So 2x cubed minus 4x minus 8 equals a, and a is 2 times x minus 1. 2 times x minus 1 times x squared plus 4 plus b, so minus 2 times x times x squared plus 4. Oh gosh, now I'm out of room. I'm sorry. So plus c times x. So x was 2, so I'm going to put, oh gosh, I'm going to get an eraser. 2x plus d. So that's c, oh, not x, 2c plus d. That's cx plus d, but x was 2, so 2c plus d times x minus 1, so 2 minus 1. Okay, so now let's see. On this side we have 8, 16 minus 8 minus 8. Oh, that'll be good. Equals 2 times 1 times 4 plus 4 is 8 minus 2 times 2 times 4 plus 4 is also 8 again. And then we have 2 times 1, so 2 times that 2c plus d. So over here we get 0 equals 16 minus, what is that, 32? Plus, and then let's distribute here to get 4c plus 2d. Oh boy. So 16 minus 32 is negative 16, so I'm going to move that 16 over as in 16 equals 4c plus 2d. I can divide everything by 2 if I like, just to make it slightly smaller. Both sides by 2 and get 8 equals 2c plus d. Okay, so what is sad is we didn't find c or d. What is good is we found an equation. So what we need to do now isn't anything very surprising. We just need to choose another x. We can do x equals 3. I'm going to use x equals negative 1 just because it's also small in absolute value. And sometimes I get tired of big numbers. You know, when you have squares, it doesn't take very long. Or we have a cube in this case. And when we have cubes, it doesn't take very long for things to get big. So it started off with 2x cubed. 2 times negative 1 cubed. I got to remember. Minus 4x plus minus 8. So minus 4 times negative 1 minus 8 equals, and then let's see, what else do we have up here? A, so a was 2. 2 times negative 1 minus 1. Oh, sorry for all the scrolling. X squared plus 4. So x squared is negative 1 squared plus 4. And then b was minus 2. And then b is multiplied by, I believe, x, and x squared plus 4. So negative 1, and then negative 1 squared plus 4. And then plus, and we have our cx plus d. So minus c plus d. And then that was multiplied by cx plus d. What was cx plus d? X and x minus 1. So negative 1 and negative 1 minus 1. All right, let's simplify. So negative 2 plus 4 minus 8 equals 2 times negative 2 times 5, right? 1 plus 4. Plus 2 times another 5, right? 1 plus 4. Minus 2 times minus 1 is plus 2 times that negative c plus d first. Okay. So that actually isn't that bad. It looks kind of bad, but let's see what it shakes out to be. This side, negative 2 plus 4, that would be 2, right? 2 minus 8 is negative 6, equals, I would say that's negative 20 plus 10 minus 2c plus 2d. So this is effectively negative 10 on this side, right? So if we add 10 to both sides, then this would be 4 equals negative 2c plus 2d. Let's do that same divide by 2 thing so that we get 2 equals negative c plus d. And then you're like, really? And then remember math 2? Maybe. If you guys even took math 2 when you were here, you guys probably started like in math 3 or 4. Well, remember systems of equations, 2c plus d. 8 equals 2c plus d. 2c plus d equals 8. So we have a system of equations, right? And when we have a system of equations, we can add our two equations together. And I guess I don't want to add my two equations together because it's not going to make anything cancel. But if I multiply this first one, because we can multiply both sides by something, let's multiply this top one by -1 so that it becomes C minus D equals -2. Like that's totally legal, right? To multiply both sides of an equation. Now if we add them together, we get 3C and then D minus D is 0 equals 6. Remember solving by elimination? So we get C equals 2. Now that we have C equals 2, we know that -C plus D equals 2. -2 plus D equals 2. D equals 4. So now we have C and we have D, and now we're ready to integrate. So let's go back to our integral. Ready to integrate. So really, remember, the long part of this is the algebra. The new part is definitely the algebra. I'm just going to copy and paste this to try to make my life easier. Let's see if it's easier or not. Let's go paste. There we go. Okay, so remember this was A, and A was 2, and A was over x. So 2 over x dx plus, and then B was over x minus 1, and it was -2. -2 over x minus 1 dx. And then C was 2 and D was 4, and they were over x squared plus 4. So 2x plus 4 over x squared plus 4. Oh man, this looks like something terrible out of our book or whatever. All right, so now, let me just make sure I wrote everything right. Yep. So now we get to finally integrate. You guys are like, oh, well, these first two are great because it's 2 natural log of absolute value of x, right? Minus 2 natural log of absolute value of x minus 1. And then this one is like not too bad, but we want to split into two integrals. And so we're going to split it up as, whoops, I didn't mean to put an equal sign, plus 2x over x squared plus 4 plus 4 over x squared plus 4. So that same idea that we're actually using to solve this whole thing is like going backwards through a common denominator process. So we're doing that same thing here. Because then on this one, we can let u be x squared plus 4, and then du is 2x dx, and we are quite happy. On this one, we should recognize that this is an arc trig, right? As a matter of fact, we should remember that the integral of 1 over 1 plus x squared dx is arc tangent of x plus c. So we need to do some factoring there. So we have 2 natural log of absolute value of x still, minus 2 natural log of absolute value of x minus 1, plus, and then this is just a du over u situation, which makes us very happy. And then this one, I'm going to move my 4 out on top, but I'm also going to factor a 4 out of the bottom, so that we have 1 plus x squared over 4. Now, just don't use u again because we already used u over here. So I'm going to use a v, and this 4 over 4 is not a problem, but v squared is going to be my x squared over 4, which makes v be x over 2. Just square root, don't forget that. It'd be the first time somebody forgot that. So we're just going to carry this stuff down. Of course, integrating this now to be the natural log of the absolute value of u. We'll fix those variables in a second. 4 over 4 is just 1. Oh, we should probably think about what dv is. dv is going to be 1/2 dx, so 2 dv is the x. So we're going to get a 2 dv over 1 plus v squared. You guys are like, oh, we know that integral. So 2 natural log of the absolute value of x minus 2 natural log of the absolute value of x minus 1 plus the natural log. U was x squared plus 4 plus 2 arctangent of v, and v was x over 2 plus c. Okay. So this really blasts us with a bunch of like, let's remember this stuff. Now, it's not the tricky stuff of the arctangents and all of that, but it's definitely some of that stuff. So there's our third type. Let me know if you guys have questions. And then I'll post another video for our second type for sure. I think that the first type you guys will be okay with, but let me know if you're feeling stuck. All right.